Okay, so topic 1 is basic skills. And let's just say, okay, it's a hot day. I put some water on the roof, okay, out here on the green roof. And I take some data like this, okay? Does anyone know what my data is? So if I go and I look at that later, what would I say? Well, it's probably time and temperature. If I just had it written down like that, that's not right. It's not very descriptive, so I should probably write down what I'm doing. So this is, let's say, time since start, and this is temp. What else do I need with that? I need some units, right? Now, time since start, well, that could be seconds, that could be hours, or that could be days, right? It's hours, okay? What do you think the temperature is? Degrees Celsius. Why? Right, because if it was 5.3, what would it be? Real cold, frozen, right? So, degrees Celsius. Okay, so, but I should write that down. Now, I would also want a narrative for my data as well that tells something about the situation that I'm taking this data. Okay, so I could say water in a, or I would say like, let's say 100 milliliters of water in a 200 milliliter covered glass beaker set on the green roof, which is right out here, on a sunny day. Okay. 10 a.m. start. Ambient air temp of 12.2 degrees Celsius. Oh, thanks. Remind me to give those to you. Okay. 10, 11, 12, 12:30 end time, ambient. I made the temperature go up a little bit too much. Ambient air temp of, since I'm going to do like 19 point. It's a lot of warming, but it's all right. It's got to be higher than the water is because it's raising the temperature of the water. So, okay, so that tells me, the narrative tells me about how the data was collected, right? That could be very important when it comes out because that's a lot different than a day where the temperature outside is 2 degrees Celsius, isn't it? And not rising, just staying at 2 degrees Celsius, right? So that sort of information is critical. So there we go. Now, next week we're going to develop a model with some math formulas based on like doing a little demonstration. And today this is just a hypothetical one. And I'm just sort of asking you, if you had this and you wanted to put a mathematical model to it, what would you go about doing first? Sam, what would you do first? What's a good way to look at and see that change? A graph of it. Good. So let's graph it. All right, so I'll graph it. You could graph it too if you want. Or you might want to wait a minute. But okay, let's see. I need some divisions on this x-axis. Okay, so let's see. My first data point is 0, 5.3. So I'll put that here. And 0.5, 7.4. Put that there. 1.0, 9.2. We'll put that there. 1.5, 11.5. 2.0, 13.7. 2.5, 13.9. So I got a good graph, or what? I find it funny, but maybe it's not. I've seen it, so. Good graph, Wendy, or what? There's no units on it. Okay, that's no good. I didn't what? No title, right? No labels. I didn't really plot up the points right either, did I? I just put them in a nice straight line, but that's not really how it's worked. So we'll throw them over there for now. We'll re-put the points on in a minute. You can bounce them up too, you see. You play a little ping pong. See, if I get bored, which is a good portion of the day, you could do things like play, shoot at the board so you could get closest. So, oh yes, there we go. So, we'll move that away though. Okay, so what do we need? Is X a good label for the x-axis? In this case, let's have our x-axis be the time in hours, or time since start. A lot of times you write that over on here, but underneath, it doesn't really matter. And then over here, temp and degrees Celsius. So now we have labels and units, right? That's good. And now we should put some numbers on the graph. So if we look over here, we go 0 to 2.5, and we have, so that's like 6 divisions. And we have, because 0.5, 1, 1.5, 2, 2.5, right? And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 6. Well, so we could make each one represent 2 ticks. So I could start here at 0, and then that could be 0.5. That could be 1. That could be 1.5. That could be 2. And that could be 2.5 hours, right? So I've used more of the graph there, okay? So that might help a little bit. I want to use as much of the graph as possible, but I don't want silly divisions. I don't want to divide it up 0.3, 0.6, for the marks, unless my data actually fit that. The temperature goes from 5 to about 16, so that's about 11. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I don't know, it's working out, but I didn't really plan it to work out that well. But 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, right? Now, I should say sometimes you're interested in what it is at the point of when the temperature goes to 0. In that case, you might want your scale of your graph to go all the way down, right? Yeah, you can. It just means that this is 5. This isn't the origin. Okay. So we're not, but that's okay. Because sometimes your data is like a rise of, say, like 32.3 degrees Celsius to 32.9 degrees. So if you tried to plot it up with 0, right, it would look sort of weird. So sometimes it's like that. But in other cases, you are interested in 0, so you would want it on there. So it depends on what it is. Okay. Our first point was 0, 5.3. So I could take that now and put it at about 5.3. Okay. The next point was 0.5, 7.4, which would be maybe about there. And then 1, 9.2. Oops. 1, so I had that one off a little bit, so now I'm trying to fix it. 1, 9.2. And then 1.5, 11.5. And then, oops, 2, 13.7. If I had a grid, it would work a little better, but about there. And then 2.5, 15.9. Okay, how's that look? Pretty close to a straight line. So if I was to fit a line to this, oh yes, you told me you were coming in late. You'll have to get your book. Maybe right after class we'll go get it, okay? Okay. So you might take your ruler. The clear ones are helpful for this exercise because you can see your data underneath a bit. It's hard for me to do on the smartboard, but you take your ruler and you try to go through the data, right? And so now I can fit a line to this. Data, like so. Get that out of the way. And now I have a, now did I go through every point exactly? No, I didn't. Because if I did, it would be like a series of lines, wouldn't it? But we're interested in getting a mathematical model for the data, okay? And I think this class is over, but the bell's not. Oh, maybe my clock's off. So we have a minute. Good. So our next step is going to be to come up with the mathematical model. So when you look at this and you think lines, what are you thinking? Y equals mx plus b. What's m? The slope. What's b? The intercept. How do you find slope? Sure, 2 points, change in y. Now do I take, okay, so he said take 2 points. So what if I took this point and this point? Okay, that would give me a line. It would give me that line. 2 points on our line, right? So we want, like, say I took a point here and a point there, like something like that. And then so next time we'll work with those points and get our mathematical model for this data.